that this is hidden is here, and we can even have a look at the source code. Well, sorry. Of course, it's disassembled source code, so it's not as nice as real one, but it's my method, so it's there. Okay, so I hope you're convinced I'm not cheating here. I'm going to hide it now and launch my script. Now, what I like is, of course, the end of it, success. Basically, I'm doing some work on the text file, and what you might like to see is that a little bit above, it sees the method this is hidden, and it's going to hide it. I'm going to show you that it's a bit above. There it is. That's the method that we're hiding here. Okay, so it's generated classes.text, where this is hidden, so it should be normally hidden. So I'm going to show you that again with underguard. Underlies. Underguard, I don't know if you use it, but it's a very cool tool. There we have a look in Mr. Hyde's class. And there we see bytes to hex in it, invoke hidden, open non-asset, and who am I? And there is no, this is hidden. Hooray. Now, it's not just underguard that doesn't see it. We can try some other tool. For instance, let's say, yeah, text to jar. Text to jar. It will generate a jar, and then we can have a look at some kind of jar code disassembler, decompiler, and text to jar, and show that. Now, I know this is awfully small, but don't worry, I'm going to make it bigger in a while. So Mr. Hyde is there. So we've got the beginning there, we've got the name, we don't see all of it. Mr. Hyde, bytes to hex, invoke hidden, open non-asset, who am I? Okay. No, this is hidden. What else have I got? I've got another decompiler which is working on the jar. To jar, and it's named Procyon or something like that. We're going to try that one too and see if it can see our hidden method. So it's in Mr. Hyde class. There we see invoke hidden. It's going to be a little bit long. Open non-asset like that. I'm going to do a grep. And we'll see if we find it. Public, Mr. Hyde, invoke hidden, open non-asset, who am I? Bytes to link, but no, this is hidden. So it doesn't see it either. What else? Yeah, with Baxmali. Let's try that one because it's a well-known tool to disassemble some Android bytecode. So I've got Baxmali here, and I'll give it my text and put the result in a directory. And Smiley, and there again, have a look here at Mr. Smiley class. Mr. Hyde, sorry. Bytes to hex, invoke hidden. We'll do the same trick. A grep is fine. Grep method will list all the methods in Smiley. So we see we've got invoke hidden, open non-assets, who am I, and bytes to hex. I hope I've convinced you here that it's invisible. And now, well, okay, so it's invisible. Now I'm going to show it back again. So this is, again, just to show you my script. Again, I'm using, actually, it's just a helper script. I'm calling, again, my Perl script, hidex.pl, with some other arguments to tell it to kind of unpatch my dex and show back that method I've been hiding. So there, and we're going to have a look. I'm not going to go through all the disassemblers this time, but analyze ddx. And normally, if everything went all right, we should see this is hidden back. There, so Mr. Hide, and list all the methods. And yes, this is hidden, is here. And I can list the source code. Okay? So, back to the slides. I hope I've convinced you there that, well, it works. It hides successfully the methods. So part of the code as well as you want, and you can also review it if you want and show it back to people who really need to see that code. Now, well, I've showed you it's working, but I'm sure you want to know a little bit more how it's working. That's actually what hacking is about, so we'll get into that. So for that, well, we have to detail a little bit what a text file looks like. Basically, there are three parts. One is the header, like most formats. Then you've got kind of a bunch of arrays of lists. And then also another section, which is data, where you actually find the stuff. In the arrays, you've got plenty of different lists. You've got lists of string identifiers, lists of type identifiers, lists of fields, lists of methods, all that kind of stuff. And they're all, in those lists, they're pointing to each other to an identifier, for instance, in the strings, or they're pointing to an offset in the text file, which ends up somewhere, probably in the data section. And that's where we're going to actually modify things in the text file to hide the method. So actually, in one particular list in the arrays, we've got a list. Each item for the class definitions is called class def item. And that references, well, different type identifiers and also an offset to an interesting structure, which is called class data item in the data section. I don't expect you to remember all the names, but it's good to have the names in case you just want to have a look at the Dalvik reference sheet, because you can do it for yourself afterwards. And in the class data item, well, basically it describes the class. So it will tell you how many fields you've got in the class, how many direct methods you've got in the class. Those are methods which are public and static, for instance, and how many virtual methods you've got in the class and which those are. And for each method, well, it's it's described through a structure which is called encoded method. And in that one, that's the very particular one we're going to hack into, well, you've got three fields, only three. It's not that complicated. You've got an access flag. That is, well, if the method is public, private, static, protected, whatever. You've got code offset. So this is going to tell you where actually the bytecode is located in the file. And you've got a very specific field, which is called method underscore IDX diff, which is a difference in method identifiers. So let me explain. What happens is that you've got a list of methods. The first method in there is going to reference the method identifier it corresponds to. Let's say this is number 13, for instance. The second method, just after that one, is going to say, okay, my method identifier is maybe 14. So I'm just showing the difference. I'm just saying increment 1, and it will have method idx_diff equals to 1. Okay? So it's just kind of a handy way to go through all the method identifiers. Now the trick. What's the trick about? Well, actually, it's just about rechaining the methods that you see in the DEX class. And what we're going to do is actually we are going to, for the hidden method, we're going to either point twice to the previous method or twice, for instance, to the next method. And that way, when people are going, well, when the code, the Android phone or emulator is going to parse that, well, they're not going to see the method in the list, actually. So what we do for that is, in that, we'll have to modify the method idx_diff field. And for the hidden method, for instance, we'll say 0. It has no difference. We're going to stay with the previous method. We also modify the method idx of the next one, so that the next one will increment correctly to the corresponding method. And then we also have to reference twice the code offset of either the previous method or the next method. And the other fields, well, you can just leave them untouched. You have nothing to do about it. You can leave the same access flag. You can leave the same sizes for the direct methods or virtual methods array. It works. Let's show it with a figure. Perhaps it's simpler that way. Well, here we've got 3 different methods, method A, B, and C. Method A references, well, the identifier for A and the code for A. Method B references the type identifier for B and the code for B. And C, the code for C and the identifier for C. We want to hide method B. One way to do that is to reference twice the first method. So we'll have B actually reference type identifier for A and code for A, right? That's exactly what I'm doing. Or other method, just as you prefer, reference twice the method which is just afterwards. Now, a little bit perhaps more advanced. I said that you don't really need to modify, for instance, the access flag. If you want to modify it, you can, but you've got to make sure that you are not modifying the access flag in a way that you would change your method from a direct method to a virtual method. So say if your method is public, which means it is called a direct method, then you must make sure that if you modify the access flag, it remains direct. You can change it to static, that will work, but you cannot do it to something totally different. That's one point. The other point also is I said, well, okay, we're going to reference either the first method, the method just before, or the method just after. So you might be wondering, okay, what happens if I've only got one method? How am I going to change it? Well, it's possible, actually. In that case, it's kind of a specific case. What you just have to do is, in the description of the class, you say that either direct methods, the array for that has a size of 0, or virtual methods, depending which one you want to hide. And you nullify all the structure for the encoded method that corresponds. And your DEX still remains valid and usable. Well, remains valid. You've got some more work to do, actually. The only kind of small work you've got to do is that you've got a hash on DEX executables. So, of course, once we've modified a few fields inside, we have to rehash the DEX and then redo the checksum. Okay? I've got a tool to do that. Anyway, it's really pretty simple. It's just it's a very small script, nothing difficult. And when you've got your new DEX modified, that is valid and recognizable, well, you've got to rebuild your application, and that is really pretty easy. You just get the previous one, unzip it, retrieve the resources, retrieve the manifest, and recreate using the patched DEX, recreate a new APK, a new application with the modified DEX. You've got to sign it also to make it useful. Right, so now you know how to hide a method and show it back again. That's cool, but I think we can do it a little bit even cooler, is that actually we can call the hidden method. We can use it once it's hidden. So this is kind of a little bit more tricky. So to show you how this is working, I built also another proof of concept application. And it's really a basic application. It's taken from a book. I don't know if you know that book. It's a well-known British book, I think. The Strange Case of Dr. Jekyll and Mr. Hyde. In that book, well, Dr. Jekyll suffers from split personalities. And most of the time, he's the good Dr. Jekyll, and sometimes he turns into a horrible man, which is named Mr. Hyde. So I kind of built an application which is a virtual Dr. Jekyll, and what I do is that most of the time that application is Dr. Jekyll, and if I manage to call this is hidden, a method, it will change the personality of my virtual application and have it move to Mr. Hyde. Okay? The only way in that application, guaranteed, the only way for it to become Mr. Hyde is to call the hidden method. Demo. Okay, so I've got an Android emulator here, and the application that I built, Dr. Jekyll release.apk. I'll show you once more that this is hidden, the method is hidden. Analyze APK, and there we go. No. Yeah. No, demos never work. There we go. Classes. Again, we're going to have a look at Mr. Hyde. Your methods. Show me your methods. Right. See, bytes to hex, init, invoke hidden, open, non-asset. Who am I? But no, this is hidden. Okay. This was just to make sure I'm launching the right one. So it's hidden. We don't see it, but though it's going to be we're going to be able to call it. So I'm going to install it in my emulator. By the way, you see that it successfully installs, which is good, which means that my DEX file is valid. The Android machine does not see anything wrong with it. And we're going to have a look there. There it is. It's that method there, sorry. Hide and seek. That's up there. And I like to show usually the logs, system logs. Meanwhile, don't worry about those for now. There we go. So I'm going to launch the application. I told you it's really simple, basic POC. I am Dr. Jekyll, and now if I press this button, it's going to normally call this is hidden, and I'll change, if it successfully calls this is hidden, it's going to change me to Mr. Hyde. Yeah, I am Mr. Hyde. I should have put an ugly picture there. I'm sorry. Didn't have time to finish that one. And we can see in the logs, well, I've put a few logs in the method, this is hidden, just to what I was debugging, and it's pretty useful so that we see we are actually going in the method, working with files and do this thing. In the end, this is hidden, done. I'm just exiting the method, and it works. So, okay, so this is hidden, but we managed to call it. So, how can we do that? Well, we saw how to do the DEX modification part so that it hides the method called this is hidden. But now how do we manage to actually run that DEX and modify it so that, well, we are able to call the hidden method? There are 4 steps. First, we've got to load, actually ourselves, to load the DEX file. And to do that, well, we use a function which is in the Android SDK, which is called open non-asset. And we're going to call it on classes.dex or our DEX file. The method open non-asset actually is not directly accessible from the Android SDK, so I've got to use Java Reflection for that. It just makes the things a little bit more complicated. It means you have to call class for name, get method, and all that kind of stuff. You see the code just below of what it looks like. But the main idea is that, just calling open non-asset. Then, when you've actually loaded the DEX, what you have to do then is to repatch it, well, to undo the work we've been doing to hide the method. So what we're going to do is we're going to give it back a correct method identifier, 1, for instance. That's just a difference, as I said. Reset again, if necessary, the access flag correctly. Reset again the code offset correctly so that it really goes to the code that corresponds to this is hidden. That's the modifications that we've got to do. And then, well, we have to open the modified DEX. And we do that with another method in the Android SDK, which is called open_DEX_file. Again, this one is not directly accessible. We've got to use some Java Reflection to call it. It has also the kind of particularity of returning a cookie, which is actually a pointer to the internal structure of the DEX. And once we've got that cookie, well, we can call another method, which is called defineClass, which will actually kind of not instantiate, but create a new class based on the modified DEX. And then when we've got our modified DEX, which is accessible, well, we have to parse it and parse all the methods and look for this is hidden inside there, okay? And we get an entry for this is hidden, kind of a pointer there, so that we're able to call this is hidden. And this is how we run the method. Actually, to exactly run the method, of course, we have to instantiate an object of the modified DEX. Then on that instantiated object, we call this is hidden with the arguments that we need for that particular case. There is a slight trick that I encountered at first. What happens is that the 2 classes, Mr. Hide, which has a this is hidden method that is really hidden, and the other one, which is repatched to show this is hidden. Well, both these classes are actually, for the Android system, they are different classes. Although they are in both cases called Mr. Hide, well, there is kind of Mr. Hide 1 and Mr. Hide 2. And that means, at the development level, well, that you cannot access from the Mr. Hide 2, you cannot access the static fields of Mr. Hide 1. So, for instance, if I was, I don't know, storing the virtual personality of Dr. Jekyll in a static field, well, it would not be working because with the modified text, I would not be able to actually modify the value of the field in the initial class. Same for static fields. So what I had to do, it's one idea among others, is to use shared files. So the split personality of Dr. Jekyll is in a shared file that both of them have access to and manage to look into and see if we are under Dr. Jekyll's personality or Mr. Hyde's. There are other possibilities to do that, of course. It's just a way of implementing things. So, hiding. So what? Is that dangerous or not? What are the dangers? Well, yeah, of course, it's kind of dangerous because if you manage in a method that you hide to put something that it's malicious, well, it will most probably go unnoticed from people who are not aware of this because they're not going to see that with their disassembler. So it's a problem. However, well, we're not, just completely stuck. There are ways to detect that hidden method. This is what I'm going to explain here. What's really important is that it's not shown to disassemblers, but the method is all the way, it's always here. The code is there, the strings are there. So if you base, for instance, part of your detection on well, looking for given particular strings, you can find it. Or if you base your detection on part of the code in the DEX file, you can find it. Okay, it's there. It's just invisible to only some tools. So if you want to detect it, well, of course, you can use, well, my tool that I'll be releasing, of course, hidex.pl, which either can hide a method or unhide it. That's one solution. Also, if you know where the code offset is of the hidden method, well, you can disassemble that particular offset. That's a possibility. Or you can look for strings, or of course, well, I've sent this hack actually to Google security team. They are aware of it, so maybe they will be one day fixing Android so that there's some better consistency check for the DEX executables so that we cannot include something inside it that is not actually being used, and that's a possibility, for instance. Final demo. Yeah, we've got time. This one is going to be about showing a little bit how to detect it. Okay, because I'm an antivirus analyst. I want to detect things. It's cool to be hiding them, but then it's not always that cool. So, I said you could detect it with the strings. So, for instance, so in classes.dex.hidden, the method is hidden. I really like Androguard. Androlyze, yeah. There we go, DX. Analyze DEX, classes, it's just completion. Decompiler, if I use it, what did I do? I didn't close the bracket. There. Guard, Mr. Hyde, and okay, the method is not there. We can't see it. Cool. But if we have a look at the strings, for instance, well, you see the strings are there. Those are the strings which are in the code of this is hidden. So this is maybe your first indication that something is wrong. If you notice that you are seeing strings, there in your application and that actually you don't see the method which is corresponding or using those strings, well, maybe it might be that the method is hidden, for instance. That's a possibility. You can actually use also the strings command on Linux. That's quite useful. And again, it's just a short way to do it. You see this is hidden strings which are there. That's a way of doing it. Now, we can also disassemble the code offset of that particular method which is hidden. Don't know if you recalled in the first demo I showed that this is hidden. The method was located at a particular offset which was 144C in hexadecimal. Well, this is 5196 in decimal. So what I'm going to do is call Python script inside AndroGuard that I kind of added to the project, and that can help me disassemble a given offset in the DEX file. So what this does, it says andro_dice, call it on classes.dex.hidden, that's the file we need to work on, and disassemble at offset 5196. Woo. There we go. Gonna do it. There. So this is Dalvik bytecode, and we actually recognize indeed that we are in the method. This is hidden. This is hidden. Set Mr. Hide. Then I'm building some new strings again, moving them, printing, putting it in a string, logging that to the Android system. Then remember we're doing some work with files, and we see that a little bit later on. Get files there. So we've got all the code there of the hidden method. So here we see, obviously, I mean, it's not random code. You can see very clearly and very easily here it's something which was written, which is in the DEX file, but for some reason, as you're getting it from an analyst point of view, well, it doesn't show. So that's the way to deal with those kind of files if ever we encounter them. And, well, I think that's pretty all I have, yeah. So you've got, well, my, how to contact me. You can follow me on Twitter if you want. The source code is nearly all of it on GitHub. I'll need to upload hidex.pl in a few days, so just wait off for a few days and it will be there. Well, I think we've got time for questions a little bit, so if you have questions, not in Hungarian, please.
Yeah, actually I have a question about it. In the first demo, when you showed how each of those tools try to disassemble the hidden code, in some instances I saw that actually one of the functions was displayed twice.
Yeah.
So this could be used to suspect that something is going wrong, possibly?
Yes, you're right. So just in case people did not hear, in some cases we see that the tool shows actually twice either the twice the previous method or twice the second method, depending on how I patched it. And so in that case, we were seeing twice open non-asset, that's a particular method. So you're entirely right. It's a way of perhaps detecting that something is kind of strange there, and possibly to look into it a little bit more. The problem with that, well, we've got to stay alert on it. The problem is that from an analyst point of view, for instance, if I see twice the open non-asset method, most of the time I'll think, oh, this is just the same name, but with a different prototype, and I won't look into it. You have to really have a close look to it and see it's exactly the same method with the same prototype, which is displayed twice. And that is not normal, of course. Yeah, go on.
Was there any malware found
No, we haven't found any malware using this so far. Actually, what happened is that 1 year ago, I went to Hash Days, which is another conference in Switzerland, and I wrote a challenge, an Android challenge for them. And I was using exactly that trick, but with only one method, where I was just nullifying all the structure and removing it. And I sent that challenge to people, and well, it turned out actually that only 2% managed to solve it, or maybe not many looked into it, I don't know. So I thought, oh, well, it's interesting then if it really gets past hackers. And I thought, oh, well, I can just actually hide one method, but could I hide whatever method I want? So I did a bit more research on that and actually found that it could work for any method. And that's what I'm presenting. Oh, yeah. Sorry. Oh. Do you have a way to get a microphone up there? Because, yeah. Oh, so I'll repeat in case I get it right. Can you hide only part of the method and point to the middle of the method? Is that correct? Yes. Okay. I have never tried, but I don't think you can, because the beginning of the code offset for any method begins with a few specific Dalvik bytecode to kind of initialize a method. So I don't think you could point in the middle, because you wouldn't have that initial bytecodes that would correspond to the beginning of a method. So I think it wouldn't work. It would be worth trying, though. Does that answer your question?
Yes.
Thank you.
What if you set the length to see it as an empty method? So you set the length of the method to give up an empty method.
So the empty methods to...
An empty method.
Yeah. Sorry, I'm afraid I didn't understand. I've got an empty method, and then?
So you just modify the length.
Well, in the case where I have only one method, yes, I have to modify the length of the table that refers all the methods. I've got to say we don't have any method there. In the case where I am just skipping above one method among several methods, I don't have to modify the length of the array. If I do, actually, it will be a problem, unless it's just the last method, because if I say, I don't know, I have 5 methods, 5 methods in my array, and I say, let's say now there's only 4, well, the last method will not be parsed. So if that's not the method you want to hide, you've got a problem. Okay. Is that okay for your question? So I think we're pretty done. Time's over.